So far, I've gone over tail recursions and head recursion. And since almost all recursions can be coded in loops, I also wrote the loop counterparts to the tail recursions and the head recursion. For this video, I am going to go over direct recursion. Direct recursion is when a function calls itself within the same function repeatedly. It is the most common form of recursion. Head and the tail recursion are specialized terms for direct recursion. Other types of direct recursions are non-head / tail recursions, tree recursions, and nested recursions. Let's take a look at this recursive function on the left side. Where is the recursion call? It's not in the head because our first statement is not a recursion call, and it's not in the tail either because our last statement is not a recursion call. Instead, it's in the middle. So this is an example of a non-head, non-tail recursion. A more appropriate description for this recursion call in the middle is a body recursion. Let's trace this function using a stack call. Here in main, I call the function and I enter the argument of 10. So I've already created a activation record for main in the stack frame, and so let's trace it. Main calls direct recursion, and I'm going to abbreviate our direct recursion function to dr on the right hand side. And every time a function is called, a new activation record is created. So here dr10 is created, and I'm going to write the output here on the lower left hand corner. Once the function is called, we jump to line 19, and inside line 19 we go into the body or the function definition. On line 21, a condition is asked. Is data greater than 0? Well, in this case, the data that we entered is 10. Since 10 is greater than 0, this condition would be true. So we jump inside the if statement. On line 23, the data is printed, and I'm just going to abbreviate print for P. And so once the data is printed, an output of 10 will be printed. And then we call the direct recursion again, but this time dividing the data by 2. And 10 divided by 2 is 5, so a call to dr5 is made. Every time a recursive function is called, a new activation record is made. So we go to dr5, and then we check line 21, is 5 greater than 0? That condition is true, and so we jump to line 23. In line 23, the data is printed, so in this case 5 will be printed. And then we call direct recursion again, and 5 divided by 2 is 2.5, but with integer data type, the decimal place is truncated, so this becomes a 2. So 2.5, I'll write it here, 2.5, this decimal place will be truncated, so this becomes direct recursion 2. And again, every time a recursive function is called, an activation record is created. Again, we jump to line 21. Is 2 greater than 0? The answer is yes, and so we print the data 2. And then we call direct recursion again with data being divided by 2. Well, let me first put print here. 2 divided by 2 is 1, so dr1. Again, a new activation record is created for dr1. We go back to line 21. Is 1 greater than 0? The answer is yes, and so 1 is printed. And again, we go to line 24. A recursive call is made. 1 divided by 2 is 0.5. And again, the decimal place and integer data types is truncated. So this becomes, after we print, this becomes dr0. So we make a call to dr0. And again, a new activation record is called, or is created for dr0. And then we go to line 21. Is 0 greater than 0? That condition is false, and so we exit this if statement, and after the if statement there is nothing left on this function, and so this function is completed and is popped off the stack frame, and the control returns back to dr1. When the control is returned back to dr1, we resume on line 25 where we print the data, and in this case the data will be 1, and I'm out of room, so this will be a continuation. So from here, 1. And after line 25, this function call is executed and is popped off the stack where the control goes back to dr2. And once the control goes back to dr2, it resumes on line 25 where data is printed. So here, print and the data for DR2 will be 2. Once data is printed, this function call is completed and terminated, and the control goes back to DR5. DR2 is popped off the stack frame. And once we go to DR5, we resume on line 25 where the data is printed. And after the 5 is printed, there's nothing left after the print statement. This function call is executed and completed, and it's popped off the stack frame. The control returns to DR10. Once the control is returned to DR10, it resumes on line 25 where the data is printed. And in this case, data is 10. And after 10 is printed, this function call is completed and executed, and it is then popped off the stack frame where the control returns back to main. And obviously once we return to main, there's nothing left after the direct recursion function is called, and we go to line 16 where we return 0 to complete the main function, and main is popped off the list. But our output should be 10, 5, 2, 1, 1, 2, 5, and 10. And let me compile this. So we have 10, 5, 2, 1, 1, 2, 5, and 10. Let me create a tree to trace this function. So on line 14, the direct recursion function is called. We go to line 19 to the function call. Then we head to line 21. Is 10 greater than 0? The answer is yes. We then go to line 23 where we print that data, so 10 is printed. And then we call direct recursion again, or we have a recursive function call on line 24 where 10 is divided by 2. And then once DR5 is called, we go back to line 19 and enter the body. Is 5 greater than 0? Yes, it is. So we print the data, which is a 5, and then we call the direct recursion again. And 5 divided by 2 is 2. So DR2 is called because, again, the 0.5 is truncated. We go back to line 19 and enter the body. Is 2 greater than 0? It is. So 2 is printed. And on line 24, a recursive call is made. So 2 divided by 2 is 1. And then we enter line 19 again. And then in line 21, is 1 greater than 0? Yes. And so we print 1. And on line 24, a recursive call is made. 1 divided by 2 is 0.5. Or 0.5, and again the 0.5 is truncated, so this becomes DR0. And then we go back to line 19 and enter the body. Is 0 greater than 0? The answer is no. DR0 terminates because it doesn't enter the if statement. Control goes back to DR1 where it resumes on line 25. Well, line 25 says print the data, so the data will be a 1. And after that is done, the control goes back to DR2. And DR2 resumes on line 25 where it says print the data, which is a 2. And there's nothing left after line 25, so DR2 is completed, and the control goes back to DR5. And DR5 resumes on line 25 where the data is printed, and so 5 is printed. And after 5 is printed, there's nothing left of the function, so the function is executed and completed, and the control goes back to DR10. And once we get to DR10, it resumes on line 25 where 10 is printed. And after 10 is printed, this function call is completed and the control returns back to main. So let me trace this to show you the output. And I'll use a different color to trace this. So we start on the left hand side and we call DR10, and then 10 is printed. And then we go here and DR5 is called, and once DR5 is called, 5 is printed. And then DR2 is called, and once DR2 is called, 2 is printed. And once 2 is printed, we go here and then call DR1, and 1 is printed. And once 1 is printed, we go to DR0, but there's nothing on DR0, so we go back to DR1, and 1 is printed. DR1 function is complete, and we go to DR2, and 2 is printed. And then we go back to DR5, and 5 is printed. DR5 is completed, and we go back to DR10, and 10 is printed. And after that, the control goes back to main. But if you look at how many function calls are made, so here we have 1, 2, 3, 4, 5. So 5 function calls are made, or 5 function invocations are made, as my college professors would term it. And so the space complexity would be O of n. And this pretty much sums up the direct recursion, or more specifically, body recursion. Thank you for watching.